A very good morning, good afternoon, good evening to my friends, participants and candidates who are taking this NPTEL MOOC course, the title of which is Applications of Forecasting, Regression and Time Series Models. My good name is Raghunandan Sengupta from the IME department at IIT Kanpur. Now, this introduction I give in each of the slides, so please bear with me. There are three main topics we are covering in this 30 hours, which is 60 lecture course under NPTEL. The first is the ideas of forecasting techniques and averaging techniques. Second one is regression models. Third one is time series analysis. And we are now covering different topics under averaging techniques and forecasting models. So, this is basically the first class of fourth week, which is fourth week and lecture number 16. Now, what we will cover today, that I will discuss, and before that I will just give brief, which I try to do before starting of each class, what we covered in the last session. The last session was basically the ideas in details. I went step by step about how you keep changing the alpha and beta values for a single adaptive exponential smoothing model. And I showed that for a changing values of alpha, changing values of beta, how you can get the mean absolute error and standard deviation. Why I keep repeating this mean absolute error and standard deviation will become clear in most probably in today's class, where I will try to point out an important aspect that the matrix which we use may not give the best result for any one model. What I mean by this short sentence, I will come back to that later. So, coming back to last session's coverage, we changed, as I was saying, that we changed the values of alpha, we changed the values of beta, and found out that we can plot the changing values of the adaptive one parameter model and check how the different values of actual values of y, forecasted values of y are. And obviously, I have not drawn the errors, but you can also draw the errors to check that actually if the data set was very large and we use the best model, so called best model, even though we are trying to utilize one of the model, which is exponential smoothing adaptive parameter model. But if we are able to use the best model and the data set was large, then the assumption, theoretical assumption of the error having an expected value of 0 with a fixed variance and normality for the error distribution may turn out to be true. But the first point, that the error average value is 0, is one of the most important thing. Variability need not be fixed, need not be 1 is a fixed value or some value, because there would be a change in the variability, especially for time series data. Now, if you remember, for all the examples we are solving, we are just giving a data set, and if it is time series, I am mentioning it. So, till now I have not solved any time series data. For the later part, for the Holt method, Holt-Winter method, we will be utilizing time series data, not specific to financial data, but we will be using the time series data with respect to, say for example, production, may be related to electricity usage. When I am using the word time series data, basically it means that we have in the x axis the time frame, and along the y axis we have the values of y, which we have as a data and we want to predict using the function f or the forecasted value. In today's coverage, we will consider a very simple forecasting example. I won't going to go into detail. So, you may be asking the question, why am I considering such a simple example now? It's just that I want to highlight that for two different models, how the comparison can be made. So, this is the main important task for today's lecture. And if the discussion continues and if we have time, Another very important aspect which we will consider is that matrix can give different answers with respect to the models, and this is very interesting. I will highlight, and then if I go into detailed solving model, which we have already done. If you remember, we have done it for the exponential moving average one parameter adaptive. So, you can utilize the same concept and try to basically highlight the second fact is that matrix may not give us the best result for any one model. So, depending on the matrix, you can get different models to be the best. And what I mean by best is basically you are trying to utilize that matrix and utilize the minimum value of the matrix to basically come up with the model which will give us the best prediction or the forecasting concept. Now, the first example is a simple one, second example where we will cover trying to compare two different models, and the third example is that where matrix can give different as example. So, rather than picking up any new concept, today's session would be only solving examples. Considering example number 13, the IIT Home Tutor Solutions Private Limited helps customer to find private tuitions and coaching centers in Kanpur city as well as online tutors. This supply business is competitive, and the ability to deliver talented as well as well educated tutors promptly is a big factor in getting new customers and maintaining old ones. The manager of the company wants to be certain that enough tutors are available at hand to meet demand promptly. Therefore, the manager wants to be able to forecast the demand for the requirement of tutors during the next month. From the record of previous orders, management has accumulated the following data for the past 10 months. I am just giving a very simple model. So, you have the data starting from January to October, the numbers are given. Now, this is time series data, yes, but not financial data. So, the data values are starting from 120 to 90. For January, it is 120, February, March, April, May. If you see the first row, it is 90, 100, 175, 110 respectively. In the second row, starting from June to October, the values are 50, 75, 130, 110 and 90. Now, what we need to do for this problem? Very simple. Compute the monthly demand for forecast from February through November using the naive method, and this is, I have been talking about the naive method, I will discuss it. Second is April through November using the 3-month moving average, we have already done. Concept wise, I will again solve one of the problem. June through November using 5-month moving average, we have done concept wise, we will do the problem. April to November using 3-month moving average, using weights of 0.5, 0.33, 0.17 with the heavier weights on more recent months. So, this is basically the concept of moving average where we are weighting it, giving weights, and nearer the value it is to the point of forecasting, more would be the weights given, and logically so. So, from the data, the naive method uses demand for the current month as the forecast for the next month, which we all know. So, y value for today will be utilized as the best predictor for the forecast for tomorrow. Now, here we are using a symbol, there is no confusion, we are using the symbol of D for the demand, which is equal to y. So, whenever I am talking about D, remember it is y, and with the suffix will denote at what time frame. So, here the data is there given in the slide. So, yt dt is equal to dt would be equal to ft plus 1, this is the naive method. So, where dt denotes the demand for time period t. So, for February we would have forecasted for February is basically y for January, which is equal to 120. In the similar way, we can write, and corresponding to that the forecast for November would basically be the actual value for December, which is 90, which means that we are considering yt would basically be ft plus 1. And if I consider that, you have done that for February, January, February being the forecast, time frame, January being the actual time frame. Similarly, you have done it for November, October, when November is for the forecast, October is for the actual. Based on that, I can find out the value. So, this is the naive method. And if you remember, when we are considering the U statistics, it was mentioned time and again, later on I did repeat it, that for y u value less than 1, you are more confident in using that model with respect to the naive method. If u is equal to 1, then the naive method and the model which you are using would give you almost the same result, and if u is greater than 1, obviously you would be more inclined to use the naive method. Now, for the simple 3-month moving average, which is the second part of the question, in that we will consider the, so I will write down and draw the time frame accordingly. So, this is for y, and if you remember, I did it in order to make the comparison for y and f more clear. Here y is d, and the line above which is dark is basically corresponding to f. So, if I have the y values, so this is y t, y t plus 1 and it continues, and I would have the corresponding value for f t, f t plus 1 and it continues. Now, if I am considering the forecast value for t plus 1, what we are considering is the following. So, there is no confusion or no error in the models which we considered earlier or the models we are considering now. So, this is considering that in that model we were considering the data is there and it will be replicated at the same time period. So, all the focus was for on y naught. If you remember, I repeated that time and again that all these moving average 2 month, 3 month, 5 month, 2 into 4, 3 into 6, 5 into 4 into 4, where the main emphasis was on trying to forecast for y naught. And I did repeat where the y naught values were for the case of, say for example, 2 into 4 or 5 into 4 into 4, such that the significance of y naught being there would give you the idea that how we are able to find out the weights which add up to 1 for all the cases we saw. And also we found out that when you draw the histogram of the weights, it turns out to be normal, which was very intuitive. Now, in this model, we will be using the idea that standing today, which is yt or dt, I want to predict or forecast for the t plus 1, which is f t plus 1. So, when I am trying to forecast for t plus 1 and if it is 3 month moving average, I will take yt, yt minus 1 and yt minus 2. If it is 2 month, 3 month is for this example, if it is 2 month moving average, I will take yt and yt minus 1. So, basically I am trying to utilize the data which is given in the past. So, in this case, when I am trying to find out yt plus 1, it will be the average for 3 values, hence divided by 3. That means, you are giving equal weightages to these values, and what are the values? It is yt or dt plus yt minus 1 or dt minus 1 plus yt minus 2 or dt minus 2 and divided by 2. Thus, we can start to forecast only from the month of April, because it is January, February, March. So, we can start in April. So, for April it will be the average of January, February, March, which is given by the actual values. I will mark them with green. So, is 120 for January, 19 for February, March is 100, add them up, divide by 3, that value comes out to be, I will use a different color, comes out to be 103.3. So, that 103.3 which you are getting, which is the 3 month moving average with equal weightages of 1/3 for each month, would be compared with the actual data which is for April. The other values may be calculated accordingly and you can proceed to find out the values. The third part of the problem is given where we want to find out the simple 5-month moving average when we use the 5 months together and equal weightages for the 5 months. So, it will be 1/5 for all. Again, I am standing today which is YT. I want to basically predict or forecast for T plus 1 which is FT plus 1, and if it is 5-month moving average, I will use the following data, which is I will use YT plus YT minus 1, YT minus 2, YT minus 3 and YT minus 4, that is 5 values. So, if I consider the formula here, I will use the blue color. The values would basically be the sum of dt. So, because d is y are same in this problem, dt plus dt minus 1 plus dt minus 2 plus dt minus 3 plus dt minus 4 divided by 5, equal weightages. So, if we want to basically forecast, we can only start from June and take the values as marked, which I will mark in orange. For January, it is given as 120. For the month of February, I am marking in green, is given as 90. For the month of March, it is given by 100, I am marking with red color. For the month of April, I am marking 75, which is given in dark red color, and for the month of May, it is given by 110, which I am marking in violet color. Adding them up divided by 5 will give you a value of 99. So, 99 is basically the 5-month moving average, which will be compared with the corresponding actual value, which is there for in the next time frame, next year it will be, because I am trying to basically predict for the next year. January to October is, say for example, for 2024, I am utilizing that data to basically predict for 2025. The other values may be calculated accordingly, and you can just find out, use the simple table which is given to find out that what would be the 3-month moving average, 5-month moving average. And remember, for the 3-month moving average, 5-month moving average, you are giving equal weights, 1/3 for the 3-month moving average and 1/5 for the 5-month moving average. Coming back to the fourth part of the problem, for the weighted 3-month moving average, we use the following formula where we are giving weights, and if you remember, the weights are given as 50%, 33%, 17%. 50% is basically the weight to the immediate value, 33% is given to the next to that immediate value, and 17% is given to the last value. So, if I consider accordingly, and if I want to basically find out for the month of April, so corresponding to the fact, now this is important to note, how you consider the model depending on how the data would come out is important, and this I will highlight as we discuss. So, please pay attention here. So, when I am trying to basically and pay attention here, I will mark it when I solve the problem. So, first let us do the discussion. When I am trying to find out FT plus 1, I am giving weightages of alpha 1 to dt or yt, alpha 2 to dt minus 1 or yt minus 1, and alpha 3 to dt minus 2 or yt minus 2. Now, correspondingly, the idea would be that alpha 1 should be greater, because there I am trying to give the maximum weightages. Now, the idea would be like this, and this is what is coming out here also. Thus, we start to forecast the value of April only, and the value given is April value will be weighted in this way. We will give weightages maximum. So, what we are doing? We have January. So, if I start from January on to the left of my hand, then you have February, then you have March, and then is April. So, if I consider the time scale. So, April, to predict that, we give the weightages I already mentioned, alpha 1, alpha 2, alpha 3. So, that alpha 1, which is 50%, would be for the month of March, because it is nearest, and we are giving maximum weightages, because the maximum amount of information from March would be utilized to predict for April. That is why it is 50% for March. Similarly, 33% weightage is given for February, and the least 17% is given to January. So, based on that, if I consider, So, April value would be given by alpha t into dt, and here alpha t and dt are the corresponding weightages and the values for March. So, if I consider alpha t minus 1 dt minus 1, it is basically the weightages and the actual value for February. And finally, if I consider alpha t minus 2 and dt minus 2, it is basically the weightages and the actual values for the corresponding of February. So, d remember is y. So, I just wanted to clarify it. So, once we, and obviously when we do that, now remember one thing, this concept which I am using of divide by 3 actually would mean that the weightages are given multiplied by 3, but actually the weightages should add up to 1. So, in this case, if the weightages add up to 1, then the factor of 3 would not be coming. So, if what I have is the first value which I marked in green is basically 50% into 100, which is for the month of March. So, if I basically utilize the second color 33 percentage, which is 0.33 into 90, is basically for the month of February, and if I use the last color violet, which is 0.17 into 120, is basically for corresponding to the month of January. Based on that, again sorry, this 3 should not be there, because the weightages are already add up to 1. So, if I basically find out the value would come out to be, I am marking in blue, that comes out to be 101.0, which is for April, which is based on the fact that I am using the moving average with unequal weights, but the weights add up to 1. Now, we will do a different problem. IIT Kanpur Furniture, so initially it was for home tutors, now it is for furnitures, makes customized furnitures. Orders are received via online request and subsequently demand is fulfilled. Formed and operated by IIT Kanpur students, the company has steady growth since it started. Due to volatility of demand, they need a good forecast of demand for their furniture, so that they will know how much raw materials to purchase and stock. They have compiled demand data for the last 12 months as reported below. So, here is the data. You have 4 columns, January, February, March is there are 3 columns, and there are 4 rows. For January, February, March is the first row, April, May, June the second row, July, August, September the third row, and October, November, December the fourth row. And the values given based on the actual values is given starting from January, February, March is 37, 40, 41, then goes to 37, 45, 50, then 43, 47, 56, and last one is 52, 55, 54. There are 12 data points starting from January to December. Now, you need to do the following: use exponential smoothing with smoothing parameter as 0.3 alpha to compute the demand forecast for January, which is basically the next year. Use exponential smoothing with smoothing parameter as 0.5 to compute the demand forecast for January, again for next year, but only in query 1 and query 2, or question 1 and question 2, which you see in the slide, is basically based on the fact that the alpha value is different. In one case it is 0.3, another case is 0.5. 0.5 means equal weightages for forecasted and actual value, 30% basically means unequal weightages for forecast and actual values. The owner Suresh Rao believes there is an upward trend in the demand. Use trend adjusted exponential smoothing with smoothing parameter alpha 0.5, trend parameter is 0.3 to compute the demand forecast for January next year. Compute the mean square for each of these methods which is used, and here we will highlight what I was talking. So, let us solve the problem. The formula to be used is as follows. So, here again remember D is equal to Y, which is demand of the actual value. When I am trying to basically forecast, the weightages are basically given as alpha and 1 minus alpha, considering there is only one parameter. So, how you put the parameters would basically depend on you. If alpha is the weightages for yt, 1 minus alpha is the weightages for ft, but the sum of the parameters alpha plus 1 minus alpha is 1. So, based on alpha into yt plus 1 minus alpha into ft, I am trying to basically forecast for ft plus 1. So, here we consider dt is equal to yt for our convenience. To determine the forecast of January, we need, January means for next year 2025. So, that data was given for 2024 January to December. So, let me continue reading. To determine the forecast of January, we need to know for December, and to know about December, we need to know about November, and so on and so forth. So, we will do the following calculation. So, for the first one, which is F2, is based on F1 and D1 and F1. Similarly, for F3, it basically depends on F2 and D2 and F2. And if I continue based on the fact that I will try to utilize for the month of January 2025, which is the 13th month. 13th month will depend on the values of 12th month actual value and 12th month predicted value. Now, remember here, in this problem only the actual value is given. So, we need to find out the predicted values which are given by the variable f with the corresponding suffix. Now, also remember, we have the actual demand from D1 to D12, which is Y1 to Y12. But when we do the calculations to find out the forecasted value, we will have the values starting from F2 to F12 first, and then based on D12 or Y12 and also the values of F12, we will try to basically forecast for F13. Again, I am repeating, we have the data from D1 to D12, which is Y1 to Y12. Utilizing the data and also having the fact that what is the weightages, it can be 0.3, 0.5, whatever it is, we find out the forecasted value F2 to F12. Once we find out F12, we utilize the value of F12 and D12 or Y12 and utilize the same value of alpha to predict for of F13. So, this is what we are doing. Based on that, when I use this calculation, so the calculation values are given, it is 30% or 0.3. So, it will be 37 based on the fact, and here also remember one thing, important thing, that the fact is that, which is very intuitive, but that the question may arise from your part. I did mention from F2 to F12. What if the student asks that can we take some value for F1? The answer is yes. For simplicity, we will consider that Y1 or D1 value which is there, you can put it as F1 also, and this is basically a starting point for your calculation, so that it will enable you to do the calculation much more easily. Now, the question somebody can ask that why use F1 value as D1 or Y1, can't we use any other value? Answer is yes. If you have the past data, you can use the average of that to basically have F1 and can do the calculation. Here we are using F1 D1 is equal to Y1, all the values are same. Based on when you do, the calculations are given for F2 is 37, F3 is 37.9 and the calculation is done till the last value is F13 is 51.79. Here is important fact, the value which you have, which I am trying to mark in violet, this 50.85 would basically be F12. Alpha we know is 0.3 and the value of D12 which is Y12 is 54 and this value of 50.89 which you already have is basically the value of F12. So, utilizing that, I would basically have the values as given, which is basically 51.79 for F13. So, with this, and the problem is not yet finished, there will be some continuation. So, considering the timing is still there, I will like to basically extend it for few minutes. Now, the formula used in this case would basically be for the 50%. So, this calculation would be done and subsequently we will consider the problem in more detail. So, the slide which you are seeing now will be repeated in the next class and we will start from there, considering alpha is now 50% and then compare the last part of the problem is basically to compare the error corresponding to the fact we are using two different weightages for doing the calculation. With this, I will end this class and have a nice day. Thank you very much.